Hello, in this section, we are going to learn one of the most fundamental concepts in ABAP development, tables in SAP ABAP. We will also understand two important components used when defining fields inside a table, domains and data element. And finally, we will move into a hands-on demonstration where we create a transparent table step by step in SE11. Data Dictionary. The Data Dictionary is a central place in SAP where we define and manage all database objects like tables, domains, data elements, views, and search help to ensure consistent and structured data across the system. The purpose of the Data Dictionary is to ensure consistency across the system, reusability of definitions, central management of data structures. Table types in SAP ABAP. In SAP ABAP, database tables are categories based on how they store data and how they are mapped to the underlying database. SAP classifies tables into different types. Understanding this table type is important because it helps where and how the data is stored, how SAP handles performance, and how different internal SAP components manage data behind the scenes. SAP provides three main table types in ABAP dictionary: transparent tables, pooled tables, cluster tables. Let's go through each of them. Transparent tables. Transparent tables are the most commonly used database tables in SAP. They store actual business data such as materials, vendors, employees, and sales orders. Key characteristics. A transparent table has a 1:1 mapping to a physical database tables. Whatever is defined in SE11, field, data types, and primary keys exist exactly in the underlying database. Transparent tables fully support SQL operations and the data can be accessed from SAP or directly via database tools. Examples include MARA, Material Master, EKKO, Purchase Order Header, PBAK, Sales Order Header. Next, we will create a custom transparent table. Here are the steps we will follow. Create a custom transparent table, define its field using domains and data elements, configure technical settings such as data class and size category, enter and display data to validate the design end-to-end. First, open transaction SE11, which is the ABAP dictionary. Select database table as the object type. Enter your custom table name starting with Z. For example, Z material DT. Click Create. To open the table definition screen, a table stores data in rows and each column represents a specific field. Each table column has a name and a data type. Every column must have a meaningful name and a type like char, numc, or date. Each cells hold a single data value. Where a row and column meet, one value is stored. In the header screen, enter a short descriptive text for your table. Set the delivery class according to the table's purpose. For business or application data, choose delivery class A. The delivery class determines how table data is treated during system installations, upgrades, client copies, and transport requests, specifying data on ship, maintenance, and transport rules. Different delivery classes include A. Application data, storing business or transactional data. C. Customizing data, used for system configurations transported via customizing request. L. Local or temporary data, holding temporary local data not transported between systems. G. Customer table, distributed an older category where SAP could add but not change entries. E. System table, for customer entries. SAP system tables extendable by customers. S. System table, SAP delivered predefined essential data. W. System administration tables, SAP delivered but changeable administration table transported as managed object. Next, I will choose display or maintenance allowed. By selecting this option, SAP allows authorized users to add, edit and delete entries in this table using standard transaction like SM30. This is especially useful for customizing tables or lookup and reference tables, where business users may need to update values without depending on a developer. Only users who have the record authorization can make these changes so the data remains secure. Next, move to the Fields tab to define your table structure, by adding fields one by one. First, we add the mandatory field, mand. I enter the field name, mand, choose the standard data element and mark it as a key field. Mand show which client the data belongs to. It is a part of primary key, so each record is identified by its client number along with the other key field. This keeps data for different client separates and avoid any conflicts. Now I am going to create the second field in my table and the field name will be material ID. This field will be marked as a key field. A key field means it becomes a part of the primary key, which is used to uniquely identify each records in the table. No two rows can have the same primary key value. In the data element column, I will enter SDE mat ID. Since it does not exist, I double click it and choose S to create it. A data element defines the business meanings of a field and provides the field labels. On the data element screen, I enter short description material ID. Next, in the domain field, I enter ZMAT ID. A domain defines the technical properties of the field such as data types and length. Since this domain does not exist, I create it. On the domain screen, I enter the short description and select the data type char. Char means the field will store character data. I set the length as 10 because material ID will be 10 characters long. I then save and active the domain and go back to the data element screen. Now I open the field label tab. Field labels control how the field name appears on screens, F for help and ALV outputs. I maintain the short, medium, long and heading labels. Then save and active the data element. Now I am going to create the next field, material name. This field is not a key field. It is used to store the name of the material. In the data element column, I enter ZDE mat name. Since it does not exist, I double click and choose S to create it. The remaining steps are similar to the previous field, so I will do them quickly. I enter the short description, material description. For the domain, I enter ZMAT name, create it, choose data type char and set the length to 40. I save and active the domain, return to the data element, maintain the field labels and active the data element. I will now define the next field, material type. All steps for creating the data element and domains are the same as the previous field. So I will only explain the value range. In the domain, I maintain the value range for material type. Here, I define the allowed values such as raw material, FG, finished goods, PM, packing materials. By maintaining the value range, SAP restricts the field so that only these valid material types can be entered. This ensures data consistency and avoid invalid entries. Now, I am going to create the next field, UOM. This field uses a building type, so I am not creating a data element or domain for it. A building type is a data type provided by SAP by default. For UOM, I select the data type unit and set the length 3. This field stores symbol unit like kg or liters. Now I am going to create the next field, quantity. Since this field uses the same approach as UOM, I will not explain the steps in detail. Like UOM, quantity also uses a building type. So there is no need to create a data element or domain. I select the data type con with length 30. After that, I save the entry and move to the currency quantity field tab, where I maintain the reference field and reference table. Here, I set the reference field as UOM because every quantity field must have a corresponding unit field. Once this is completed, I proceed to configure the technical settings for the table. Now, I will open the technical settings screen. Technical settings define how and where the table data will be stored at the database level. Inside this screen, I must maintain two important parameters. Data class. The data class tells SAP where the physical data of the table should be stored in the database. It helps SAP group similar types of tables together for performance optimization. SAP provides three standard data classes: APPL0, master data, stores data that does not change frequently, mostly read often and updated rarely, used repeatedly in business process. Example: customer master, vendor master, material master. APPL1, transaction data, used for data that changes very frequently, highly dynamic and grows rapidly, represents day-to-day business transaction. Examples: sales order, deliveries, billing documents. APPL2, customizing or system data, stores configuration and control tables maintained during system setup, rarely changed during daily operation. Examples: customizing tables, system control tables. Since material details do not change frequently and are mostly read during reports and processing, they are considered master data. Therefore, I will select APPL0 as the data class. Size category. The size category defines the expected data volume the table will store. SAP uses this information to allocate database extents and improve storage performance. 0. Very small data volume. 1. Few thousand records. 2. Hundred of thousand of records. 3 plus very large enterprise level tables. Since this custom material table will contain a limited number of records, I will select size category 0. Even if the allocated memory for size category 0 becomes full, the database will automatically extend the storage space. The table will continue to grow without any issues. After maintaining the data class and size category, I will save and active the table. Finally, I will return to the main screen. Now the table is fully active at the technical level. Now that our table is active, the next step is to enter and display data to verify that everything works correctly. To insert data manually, go to More, Utilities, Table Contents, Create Entries. This opens the data entry environment for our custom table. Here we can manually insert new records, use autocomplete for fields defined with the domains, trigger validations such as length checks or data type checks, save entries directly into the SAP database. Now, I will enter the sample data. Click Save. After saving, the new records are stored physically in the underlying database table. Displaying the stored data. To view the records saved in the table, go to More, Utilities, Table Contents, Display. Inside the display screen, we can view all stored records, apply filters, sort data based on any field, verify that values were stored correctly. This completes the end-to-end validation of the table design. Now, I will move on to the next type of tables, such as pooled tables and cluster tables. Pooled tables. Multiple small logic tables are stored together in one physical database table known as table pool. Why pooled? To optimize space and performance when dealing with thousands of small tables that hold configuration or customizing data. Key points. Each row in the pool has metadata to identify which logical table it belongs to. Access is via ABAP Dictionary only. Cannot run SQL select star directly on pooled tables. Stored in compressed format, ideal for customizing tables. Cluster tables. Table clusters are special table type in ABAP Dictionary. The data from several different tables can be stored together in a table cluster. Cluster tables store data in a compressed cluster-like format. Multiple cluster tables are stored together inside a table cluster. Why clustered? To store logically related data together to save space and speed up access when reading data in one go. This type of storage improves performance for large data sets. Key points. Useful for complex, dependent data. Stored, compressed, and not directly readable via standard SQL tools. Performance is optimized for bulk reads. In this section, we learned how to create and manage a custom transparent tables in the SAP ABAP Data Dictionary from start to finish. We understood the core concepts, domains, data elements, table types, and technical settings, and then completed a full hand-on demonstration in SE level. We create a table, define all fields, set the delivery class, data class, and size category, activated the table, and finally entered and displayed data to ensure everything works correctly. By completing this exercise, you know how to design, build, and validate a fully functional table in SAP ABAP. Thank you.